name is Riley Potter, and I am a Jackson River Governor student because I found I have an interest in science and mathematics, and I wanted to explore this interest some more. So, with that, have you guys ever wondered how to find the circumference of the Earth? Sounds super complicated, I know. But today, I'm going to show you a super simple way. All you're going to need is a big long pole, the sun, and maybe a protractor. So, let's get to it. Alright guys, so the first step in finding the circumference of the Earth is to first get the measurements of your shadow, of your pole. So, I am about to show you the exact place where I found the average length of the shadow. So, come follow me. So, as you can see, I have here listed, we have our trusty pole and our pole holder. Thank you. We have our tape measure. We have a nice long string that will extend, making our triangle, because this is all about triangles. And we have our protractor. This protractor is actually made out of a sticky note. So I'll show you here. It's actually made out of a sticky note. So if you would like to make your own, go look on YouTube. Okay, so this would actually happen at about 1 o'clock at this time since it's daylight savings time. But since the sun isn't exactly out, we're just going to pretend. So the shadow would come down and you would line up the shadow of the pole with the tape measure on the ground, just like this. So we are going to pretend that the shadow ends at 4 feet. So now that we have this measurement, we're going to write this down, and every so often, and maybe every 2 minutes, you're going to take another measurement, see how much it changes. So once we have that, make sure your dog is in it as well. Finn. Go over there. Okay. Once you have that, you want to find the angle measure. Remember this angle measure because it's going to be very important. So with your partner, this is why you're going to need another person. One person is going to take the string, they're going to extend it all the way down. We said it was 4 feet, so I'm going to put it right at 4 feet, make sure it's tight. Then our partner is going to grab a hold of it, make sure they got it tight, make sure the angle doesn't change. All right, come on over. He's going to move his hand, make sure you can see the angle here, and we're just going to line it up with the protractor here. So you see it comes up to about 30 degrees. So that is now the degrees that we are going to use when we are getting our circumference of the Earth. So this is mainly the stuff that we do outside. Make sure to get multiple trials, and later I'm going to tell you which trials we're going to use. Alright, so now that we have gotten all of our measurements, we got to put them into a nice table so that we can see some of the changes that happened. So I personally did this experiment on 3 different days. So the first day I did it at 12, and you can see I have my 2-minute increments. And at the end, this is my second day, and I averaged these 2 days, so here's my average. And then my third day, we did it at 1 o'clock, or around 1 o'clock. So the average for that day is this. And since this measurement is probably the most accurate, this is the one that we are going to use to determine the circumference of the Earth. All right, now we are going to work on finding the circumference on paper. So, first step is to find the latitude. So the latitude where we determined the length of the shadow. So if you go to latlong.net, you can type in your address and find your latitude. Mine was 37.498. I'm keeping 5 significant figures because that's how I want my final answer to be. That's just something extra to do. Step 2 is to find the distance from the equator. So you're going to take your latitude and you're going to multiply that by 69. 69 is the number of miles in one latitude mark. So to find the distance, you multiply those. I have 2,587.4 miles as my distance from the equator. Step 3, we're going to convert miles to kilometers because the world uses kilometers. So that's what we're going to use. So we're going to take this number, our miles, and we're going to multiply that by the conversion number, which is 1.609056 figs, which is going to get us to 4,163.1 kilometers. So this is this same number, just in kilometers. This is our distance from the equator. All right, next step is to find our angle measure. If you remember, I showed you exactly how to do this outside. You take with your protractor. So we had a 30-degree angle measure. Remember this number, the distance, and the angle measure. So now we're going to relate our angle measure to a circle because the Earth is a sphere. So we're going to have 30 degrees over 360 degrees. That's the number of degrees in a circle, which is 1/12. Now, if you think about this, 30 degrees to 360 is 1/12. We're 1/12 of the Earth. Okay, and next steps, we're going to now relate the distance to the unknown circumference. So the distance that we had gotten from the equator, which is 4,163.1 kilometers over x. This is what we're trying to look for. Now, if you haven't figured it out yet, we are now going to set up and solve the proportions. So we have our angle measures on this side and we have our distance on this side. And to solve a proportion, we're going to do this kind of butterfly effect. So 30x equals this times this, which is 14,000, which is 149,816. There's a lot of numbers in that. That's okay. And we're going to divide both sides by 30 degrees. So here we have x equals 49,957 kilometers, which is our circumference of the Earth by our calculations. Okay, so now that we have the measurement of our circumference, what does all of this mean? So I want to point out that the actual circumference of the Earth is actually 40,096. So just a reminder, we got 49,957 kilometers. So we were only 8% off. Some other people who have also done this experiment, Curtis Bott created a video called How I Prove the Earth is Round with my bike and 2 sticks. He ended up getting 33,120 kilometers, which was approximately 17% off. That's pretty good. Then we have some people back in early centuries. We have Ptolemy. He got 28,985 kilometers. He had the shortest circumference. He was 28% off. And actually, because he was so off, it was actually the reason Christopher Columbus decided that he thought that the circumference was small enough to go all the way around. If Ptolemy wasn't so wrong, maybe we would have never been discovered. Then we have Poseidonus. He got 38,647, so he was 30% off. Excuse me, he was 3% off. So he was also pretty close. And then the closest of them all, and also the first one to do the experiment, was of course Eratosthenes. He got 40,000 kilometers and was only 1% off. So you see that just using some simple steps, we can come up with a pretty accurate guess of what the circumference of the Earth was. All right, now we are going to work on finding the circumference mathematically. So we will actually not be using the average length that we just found, but we will be using the angle that we did find outside. So keep that angle measure in mind. We had 30 degrees. So step 1 is to find the latitude, where you took the measurements. So I simply went to latlong.com, or excuse me, latlong.net, and found that my latitude, I spelled latitude wrong.